Joe Conway. He came from San Diego, California, United States. He works for Credative. Actually, it's his company. He's one of the partners of the company. So he will talk about PLR, what it is, and how can you use it, why do you have to use it, what is the importance of it. So Joe, please feel free to start. Go on. Welcome.
Thank you. So first of all, I'm sorry I cannot speak Portuguese for you, but I'll do my best to speak slowly, and if you want to stop me, just tell me. PLR is a project that I have written and maintained now for over 10 years, and it's an extension to Postgres. Oh. So first of all, it sounds like some people here are familiar with R, but some people maybe are not. I'll just show you briefly. If you've never seen it, this is the R website. It's rproject.org. R is very popular in schools, in universities. It's very popular in research. It's very popular in bioinformatics, in quantitative trading, in a lot of areas. Much of the most cutting-edge mathematical science is first implemented in R before anywhere else, because of the fact that it's being used so extensively in universities, but also in many high-tech industries. I won't spend much time looking at this, but I did wanted to show you. Let's just go to any mirror. I'll go look for it later. There's a there's a page on the R site that I can find later on. It's called Task Views. It's probably the most interesting page on their site if you're not familiar with R. One of the most interesting features of R is that it's very easy for people to write packages that extend the capability, that add new types of analysis. That's why new analysis tends to be developed in R first. And because of that, on their site, there's links to 4,000 or 5,000 different packages that you can use. And it can be very hard to find the one that is most applicable to your problem. But these task view pages are organized by topic. So there's a task view page that shows you all of the packages for artificial intelligence. And there's one that shows all of the packages for high performance computing, and so on. So I'll try and find that later. I don't want to spend too much time looking for it in the middle of the presentation. But if you go find those pages, then you'll see all of the packages for a specific topic. So it's very useful. Postgres, it sounds like, again, some people are familiar with Postgres and some maybe not so much. But Postgres is a database just like Oracle. In fact, I would argue it's very, very competitive with Oracle in almost all situations. I've never personally run across something that ran in Oracle that could not also run in Postgres. Of course, you need to do a migration. Migrations can be difficult, but you may have to rewrite some things. But by and large, Postgres operates very much like Oracle and can handle the same types of loads in most situations. One of the main advantages of Postgres is, again, just like R, it's built from the beginning to be extended. So for people to add features to Postgres. And that's what allowed me to write PLR. PLR is a wrapper. What it does is it takes the R language interpreter, so the part of R that parses the code syntax and executes, and it embeds that inside of Postgres so that you can write SQL functions and run them in the database just by simply saying select my function, and then that will use the R interpreter. It'll use the R engine to do the calculation, and then it will return the result to SQL. Does that make sense to everyone? And One other thing I'll note now, I have two versions of this presentation. In the interest of time, I'm giving a short version that's a little bit more focused on, I think, what is most interesting to you. But I also have this version is 23 pages, the other version is 82 pages. You don't have enough time for that today. But it's more like a full training. It covers all of the features and in some detail. And I will make both copies available to 4Linux so that they can give those to you if you want. And we also have a mailing list for the PLR. You can see down here at the bottom, it's kind of small, but on this slide, I have the link for Postgres, and I have the link for my website, which is where PLR is located. And on the PLR section of the website, there's a link for how to get help, which will send you to a mailing list for PLR. So if you want, it is an open source project. If you want to join the mailing list and ask for help, you can do that. So now I'll talk about some of the reasons why you might want to use something like PLR instead of using R or SPSS outside of the database. One of the main reasons, I think, is that when developing a complex application that may have data and it has analysis that needs to happen and it has maybe a web front end that's presenting the information to people, you want to be able to leverage people's skills in the best way. And so you don't want your web developer to have to know how to do a linear regression model on the data. You'd like your web developer to write, select, give me an answer, and have it show up on the site so that the web developer can focus on getting the information on the page for people to see. And you have statisticians, people who do math, who know how to do the analysis, and you like them to write in R. By using something like PLR, you can do both things. You can have your statistician develop some analysis, parameterize it so that it takes arguments. You can do QA on it. You can create a function in the database that now is not easily changed by just anyone. Only the DBA can change, and the web developer can just call it. So you can leverage people's skills. You can leverage your hardware. If you use SPSS, you probably use it on your laptop. Your laptop maybe has 4 gigabytes of RAM, or maybe more if you're lucky. But your server for your database might have 32 cores and 128 gigabytes of RAM. So with all of that RAM on your server, all of those cores, you might as well use them. Bandwidth efficiency. If your analysis takes 1 million rows from the database and does some kind of calculation on it and puts out a graph or puts out just an answer, the number 42. Some people understand that? So why would you want to send all of that data across the network to your laptop and do the number crunching to get 42? Instead, you do the calculation on the server. The R process is right inside the Postgres process, so it has very close access to the data. It does the calculation as efficiently as possible and then just sends the answer. As I mentioned also earlier, consistency of analysis. So if your statistician writes a function, they can develop their function in R interactively until they get it the way they want. And then you can cut and paste into a PLR function. And now you're sure that every time a certain type of analysis is done, it's always done the same way, and it's done with the function that was vetted, the one that was QA tested. And there's abstraction of complexity. For the web developer, you don't want the web developer to have to think too hard about the math. They don't typically know the math or want to do the math. They want to do something simple. So all the complexity behind that analysis is hidden in that function, and they just need to know to call it. And then finally, leveraging of R. As I said earlier, R is a huge ecosystem with many, many, many different types of analysis available for you to use. And so this capability extends Postgres by a large amount. Some of the reasons why, some of the negative things about using PLR. If you're a Postgres user and you're doing something, in SQL you can do, there's a SQL aggregate for standard deviation. And if you're doing a standard deviation, you could write standard deviation using PLR. It'll work. But it will be slower. The built-in functions are faster. So if there's a function built in, don't use PLR. But there's many functions that you can do with PLR that are not built in that would be very difficult to do otherwise. And R is not an easy language to learn. It's very different. So if you've never programmed it, if you're a database guy and you're trying to write your own R functions, it might be some learning curve. But as I said, you could also have your statistician who knows R. I'll show you an example later. You could have your statistician write the R code and you could cut and paste. But if the database guy needs to write R code, it takes some learning. And believe me, I know some R, but I'm not an expert in R. R is a very difficult language. If you're an R user, you would not want to write your R code directly in PLR, because once it's in a SQL function, debugging is more difficult. So it's useful to write it in the R environment, and then you can do your debugging easily. You can refine it, get it to where you want, and then move it. So it's less flexible if you're doing ad hoc analysis. If you're just trying to figure out what you want to look at and what types of analysis you want to do, again, you wouldn't start in PLR. You'd want to start inside of R itself. And again, if you're an R user and you're being asked to work with a database, maybe you know nothing about a database, then you have to learn SQL maybe. Or maybe you don't. Maybe you just hand it off to someone else and they cut and paste. So when you create a function in R, this is what it looks like. It just, you give the function a name, and you use a keyword function, and you specify some arguments, and then you have this function body, and the function body would reference these arguments. That's what it looks like in R. In Postgres, this is exactly the same for PLR or for any other function in Postgres. If you're familiar with, Postgres comes with built-in language called PGSQL, which is very similar to Oracle's PL/SQL. If you're familiar with PL/SQL, it looks very, very similar. The only difference is that you do create or replace function, you give it a name, again, you give it argument types. The function body in here looks exactly like the function body in here. And it references the arguments. If you don't give the arguments names, then PLR just defaults them to arg1, arg2, and so on. In Postgres, it does, Postgres in more recent versions, old versions, when I first wrote PLR, did not support named arguments. PLR has been around a long time. Postgres for at least 5 or 6 years probably has supported named arguments. So if you name the arguments, then those argument names are used inside the function body. But you specify the language PLR here. So you could use language SQL, language PL, PGSQL are built in. Postgres also ships with PL Python. It ships with PL Perl. It ships with PL Tickle, if you like TCL. So this is just another of the same type. And these languages all work the same way. They load, so a PL Perl loads a Perl interpreter and transfers arguments into Perl and then runs the Perl interpreter. Same way. Is this clear? So here's a more practical example. When you add extensions to Postgres since 9.2, I think, the latest release, no, 9.1. 9.1. So the latest release of Postgres is 9.2. Postgres comes out with a major release about once per year. So for almost the last 2 years, use this syntax, create extension PLR. So you have to install it first at the binary level. Depends on your operating system. If you use Ubuntu or Debian, there's a PLR package. Red Hat, you need to, there's an RPM, but you get it from the Postgres RPM repository. CentOS is the same as Red Hat, yes.
The community repository.
The community repository, yes.
Install any
But Ubuntu actually has it in the main repository. And if you use Windows, you can get a DLL from my site. It's very difficult to compile Postgres or extensions on Windows. But anyway, once that's installed, you just say create extension, and then you create the function as we saw. In this case, I've said these are out, which is just standard Postgres, meaning these arguments are actually being returned. They're not going in. And that's very similar to Oracle also. In case you're not familiar with it, in Postgres, the body of the function is really just, it's called a string literal. It's just a string. And in Postgres, it supports something called dollar quoting. This double dollar sign allows you to quote a string in a way that you can have embedded single quotes so that you don't have to double them or quadruple them. Or if you've done anything with embedded quotes in strings, it can get very ugly very fast. So dollar quoting is actually very nice. So in this example, R uses a data frame in R is like a table in Postgres. It's just rows and columns, and the columns can be different data types. And so in this example, I'm just creating a data frame using the letters A, B, and C, and the numbers 1, 2, and 3. And then I can just say select star from function. And that returns two columns and 3 rows. So very simple. So now I'm just going to cover a few special features. And as I said, in the long version of this presentation, there's many other features, and you can browse through and ask questions later. Weeks from now if you want, it doesn't matter. You can send me an email or you can sign up for the list. So there's a package for R. It's called R PostgreSQL. And it's similar to, if you're familiar with Perl DBI, or in Python, there's something called PsychoPG. It is an extension to the R language that lets you query the database and pull back data into R. And so if you're using R itself, not PLR, but R all by itself, and you need data from a database, you can use R PostgreSQL to run a query against the database, and it pulls back the rows and it creates a data frame for you. And that's kind of standard functionality for people who use R with databases. There's R Oracle, and there's R MySQL, and there's R ODBC, and so there are connectors to other databases as well. But these are the main functions that you use with R PostgreSQL. You select a driver, which would be Postgres. You connect to the database. You send a query. You fetch results. And then there's some other functions you might use. In order to make it easy for people who are using this to cut and paste between R and PLR, I have added the same functions inside of PLR. So when PLR pulls in the R environment, it adds extensions to R. So PLR is an extension to Postgres, but it also adds some extensions to R automatically for you. And one of them is a compatibility layer with this R PostgreSQL. So for instance, this function is written in R. And in here, I'm using this package TSP, which calculates, are you familiar with the traveling salesman problem? Anyone not familiar with that? No? Traveling salesman problem, let's say you have 100 cities all over Brazil, and you're a traveling salesman and you want to travel most efficiently, save gas. So you need to figure out what's the most efficient route amongst these 100 cities. It's a very difficult problem to solve. It's basically impossible to get the perfect solution, but there are packages that will get you a very good solution, and R has one. So in this case, I'm using Traveling Salesman library, and I'm using this R PostgreSQL library. So I use the driver Postgres, I connect to my database. This is my SQL string. I'm selecting locations in this case. Is everyone here, anyone here familiar with PostGIS? PostGIS is another extension for Postgres that allows you to do spatial geometric queries. So it's used very often for doing maps. You can have roads, you can have streams, you can have boundaries of states. It has all of the capability that commercial geospatial packages have. It's very, very powerful. In fact, many people find that Postgres with PostGIS is better than Oracle Spatial, and it's equivalent or better than other commercial packages. So in this case, I'm pulling data from a spatial table on locations, and then I'm defining those to a variable called waypoints. Waypoints are points along a map. And then I calculate, I solve the traveling salesman problem right here. So this is just a little more than a dozen lines of code, queries the database, solves the traveling salesman problem, which is very difficult, all done in R. So now if I take the next slide, you notice the only thing that changes is the decoration, this part. So because of this compatibility with our PostgreSQL, you can just cut and paste. And then if you run this in R, it looks like this. You just call the function by typing it. And if you call it from Postgres, you just select it. This is another interesting feature. Again, this is not specific to PLR. This is Postgres Extensibility. Postgres lets you define your own aggregates. You're familiar in general, in SQL, aggregates are average, standard deviation, count. So you have groups, and then you do some calculation on the group. How many there are, what the average is, standard deviation. Those are in every database. But what if you want to do Quantile? Quantile breaks up your data into 4 groups and gives you the breaks where your data is broken up. So in Postgres, you can define your own aggregate by using what's called a state transition function and optionally, possibly, a final function. And the way it works is for every row in a group, the state transition function gets called with the column that you supplied. So if you do average column so if you do average column F1, then for each row in that group, group by F2. So for each column in group F2, some function, state function, gets called with the value of F1, but it also gets the result of the state function from the previous row passed in also as another argument. It's invisible here, but it's underneath. And that gets carried down for each row in the group. And at the end of the group, the final function will get called with that final result. So the last value that gets passed back gets passed as an argument to the final function, and a calculation is done. So for something like count, count does not need a final function. Something like average, the state function is summing and counting, and the final function takes the sum divided by the count and gives you the average. That's how that works. And you can define an initial condition for the state function so that on the first row you have some initial condition for the value that gets passed in. So this is an example with a quartile. I just explained what quartile is. It's very easy in R. There's a quantile function in R, so it can do an arbitrary number of bins. And in this case, I just say I want to take the interval from 0 to 1 divided by in quarters. So I'm going to make it a quartile. And I'm going to pass in an argument which is type any array. Now this is part of Postgres functionality. It's called polymorphism. The function can take different data types. So this way I don't have to redefine it for integer, 8-byte integer, floating point, 4-byte floating point, 8-byte floating point, numeric. Just define it once and use it. And then this is how you create a custom aggregate. So I create an aggregate called quartile. It takes type any element, which is the same thing, except in this case, I'm taking an array of something. In this case, it's taking a value, scalar. It uses a state function, sfunc, called array append. Array append takes the one argument, which is an array, and it takes the other argument, which is a single scalar, and it appends it to the array. So it just keeps making the array bigger. And then the final function is my R quartile, which takes the array, the final array, and it does the quantile function as I've defined here using that array. So when I call that, this is data from a place where I used to work long ago. It's manufacturing data. And each of these is a different person doing the work, a workstation. And this gives me the quantiles of a certain value grouped by workstation. So I can see how well is each workstation performing compared to the others. And so it's not easy to look at the data this way. So with R, you can also graph it. This is what the graph looks like in a box plot. So this is interesting because now you can see this shows that this workstation has a very, very tight variation. This one has a very wide variation, and this one does not even overlap with this one. So these are producing different product. So there's some problems here. And you can see that very easily. Window functions are another feature of, they're defined in the SQL standard. I believe Oracle supports window functions. I know DB2 supports window functions. I think SQL Server supports window functions, yes. So the idea of a window function, it's similar to an aggregate, but it's different. You have what's called a partition. So it's part of the data, maybe defined by data by state or by company or something like that. And then within that partition you have, it's called a frame. It's a sliding window inside of the partition. And when you do calculations on window functions, you have access to all of the data in that frame. So, but you produce an output row for each row. So in aggregates, you have all the rows in the group produce one row. But for a window function, each row in the group produces a result, but the result could be based on other rows. And so this is my fancy graphic to illustrate. So this is a partition here, and this is the frame, and the yellow row is the current row that we're on, and everything inside the frame that's not pink is accessible. So the rows have to be in the frame and in the partition. So this is an example of one. It may be a little difficult to understand in a short presentation, but I'll give you an overview. This part just creates some random sample data. It's just for illustration. The idea of this example is a company who has an earning per share, and we want to see if there's any relationship between earnings per share this year if I know what my earnings per share were last year. So this function is going to find the slope. It does a linear model, a regression on the data of this year's earning per share versus last year's earning per share, and then it gives us the slope. So it gives us the relationship between earnings per share, which the idea is to allow us to predict earnings per share, because if you can predict earnings per share, then hopefully you can predict stock price. This example came from a real example. It was a professor at Harvard who sent it to me. It's obviously simplified a bit, but it has real use. So in this case, this is, again, very small function in R. With a window function, there are these special arguments, farg, which are all of the rows that are in the frame. So for my first argument to the function, all of the rows that are inside the frame are in a vector called farg1, and for the second argument, they're in a vector called farg2. So that's how I access them from inside R. And then this just uses an R function called lm, linear model, to calculate the slope. So this is how you write a window, you use a window function in Postgres. This is really, this syntax is not specific to PLR, this is Postgres. So in this case, I've defined the function here with a special keyword window that lets PLR know that, and Postgres know that this is a window function. And then I can call it in this context. And this is how you write a window function. So I'm saying I want the 8 preceding years for each row to be in my frame. And when I wrote the function, I said don't calculate unless there was at least a certain number of rows. Because if you don't have enough rows for a regression, then it's meaningless. So you need enough data points to plot a line. So in this case, the output here, EPS is my current year earnings per share. Lag EPS is the previous year earnings per share. And I'm feeding those as arguments to my regression, my PLR function, EPS and lag EPS. And here I plot the relationship between last year's data and this year's data. And again, this used random data, so the example itself is meaningless, but hopefully it gives you an idea. That's it.